Our third video lesson is about parts of an atom. Up until now, you've learned about the physical and chemical properties used to identify different elements. But what makes each of these elements unique? Our objectives for tonight's lesson is that I can compare different parts of an atom. I can also explain how parts of an atom relate to an element's physical and chemical properties. Scientists know of 118 elements that currently exist. 92 of these elements are naturally occurring, with the rest being formed by man. Elements can be identified by their physical and chemical properties, and each element has a unique set of physical and chemical properties. So for example, the cream soda can here is made up of aluminum. And we know from our previous lessons here that aluminum is a metal. It conducts electricity, it's malleable, it's a solid. It's also very lightweight. It's perfect for keeping soda cold because it also conducts heat really well. But what makes the soda inside of the can different from the can itself? And that comes down to the atoms that make up each of the elements that are involved. And so if we were to go ahead and zoom in on our can of soda here, I would see that the can itself is not just a solid object, but instead is made up of lots of little atoms. And each atom of aluminum is exactly like every other atom of aluminum. And these atoms are much smaller than bacteria. You could see individual atoms with an electron microscope or an atomic force microscope, but all matter is made up of atoms. And so for our parts of an atom that identify what kind of element it's going to be, we have protons, neutrons, and electrons. And so in your note guide tonight, I've provided you a table to complete as we go through this on the different parts of an atom. And we're going to use this information in our lab tomorrow where you're going to identify the rules that go into determining what makes an element unique. To start off with, protons have a positive charge, they're located in the nucleus, and they have a mass of 1. And so your question might be, well, what's the nucleus? And so if I were to draw a picture of our atom over here, and you're going to do a lot of these drawings here, the inside circle is our nucleus. And so a symbol that we could use for protons would be a positive or a P for proton. And so I'll put a proton here in the middle. But I'm going to do it in green to indicate that's a proton. Our next part of an atom is going to be that of a neutron. And a neutron, just like the proton, is located in the nucleus of an atom. But it's different in that it has no charge associated with it, and it also has a mass of 1. So if I were to draw our model of the atom here again, I'd put the neutron here in the nucleus. And to signify neutrons here, I generally use either a 0 or an N for neutron. And so I'll put that in the middle. We have one more part of the atom to look at, and that's the electrons. And the electrons, which we're going to learn more about in the future, really determine what the chemical properties are for an element. So an aluminum atom behaves like an aluminum atom because of its electrons. And so if I were to draw our model of an atom here again, the atomic structure here, I would find that electrons here have a negative charge. They are not located in the nucleus, so they're located in electron shells. And so if I draw these arrows here, these outside circles outside the nucleus are my electron shells. And then our symbol for an electron is going to be either just a negative sign or an E with a minus sign. Now, like I said before, the mass of an electron is 0, and if we were to compare that to a proton or a neutron, it would take about 2,000 electrons to equal the mass of a single proton. We're going to finish up tonight's video with a review of the parts of an atom and the role that each subatomic particle plays in the physical and chemical properties for a given element. To begin with, I'm going to start by drawing our atomic structure of an atom. And so I would draw my nucleus in the middle and then 3 electron shells around. And as I said before, I'm not much of an artist, so excuse those should be circles. But moving on here, the subatomic particle of the proton is found in the nucleus of an atom, and it has a positive charge and a mass of 1. The subatomic particle of a neutron also goes in the nucleus of an atom, which we're going to use the symbol 0 for it because it has no charge with it. It also has a mass of 1. The last subatomic particle that we need to get onto our atomic structure here is that of the electrons. Now, as I stated before, the electrons determine what the chemical behavior for an element is going to be. It also determines the chemical behavior of individual atoms. These electrons are arranged in a very special way around the nucleus of an atom in electron shells. And there's a certain order that electron shells are filled. And so starting closest to the nucleus here is our first electron shell, and that's the first one that's going to be filled. And then from there, we'll go to the second electron shell, then the third electron shell. You do not move to any of the outer electron shells until you have completely filled the number of electrons for the first one. Then you fill the second one, then you fill the third one. Now, the first electron shell can hold a maximum of 2 electrons. The second electron shell, if needed, would then hold a maximum of 8. Doesn't matter where you place the electrons in that shell, but a maximum of 8. So an element like neon, which has 10 electrons, would need to have 2 in the first electron shell, then would have to have 8 in the second electron shell. If we were looking at fluorine, fluorine would only have a total of 9 electrons, with 2 in the first and 7 in the second electron shell. If you then need the third electron shell can also hold a maximum of 8 electrons. I will not expect you to draw any of the electron structures for atoms higher than argon, because once you get beyond 18 electrons, the electron shell system doesn't work. Tomorrow when you come in, we're going to be going to the computer lab, so you need to be ready to go, know what your login ID is. You'll be able to work with a partner. We're going to go through a computer simulation that's going to help you learn the rules for different atoms and the subatomic particles that go into each atom and each element. With that, this is the last part of our video lesson, and I will see you all tomorrow.